use a calculator to solve the equation on the interval 0 to 2 pi and then round your answers to 2 decimal places. I have decided to underline these numbers because they are these words, because they are very important. Now the question which you're told to solve is to solve for theta is tan theta equals 3.2. The tangent of theta equals 3.2. So you want to solve this equation for angles that lie between 0 and 2 pi. Now how do you go about this? So what you would observe in the past videos that you have watched, you would observe that all I have said is anytime you want to find the trigonometric function of any angle, now what is most important is the reference angle and nothing at all. No matter how big the angle can be, 1000, 500, 700, what is most important is the reference angle and then the quadrant where the angle lies. That is most important. Let me go ahead and solve this problem so that you see what I'm talking about. Now the question we have here, which is 53, is we're given the tangent of theta to be equal to 3.2. So the first thing I'm going to do is, or anytime you have any problem like this, the first thing you should do is find the reference angle. Now to find the reference angle, that is theta ref, since the tangent of theta equals this, so to solve for theta is as if you're dividing both sides by tan. So it's like saying the arctan of 3.2. So the arctan of 3.2. So when you find the arctan of 3.2, this is going to give you the reference angle. Now note, what the question says is the tangent of an angle is positive, is greater than 0. So find that angle such that you have 3.2. Anyway, let's go ahead and find the reference angle so that you see what I mean. So let's bring our calculator up. We go on. Then we want to find the arctan of 3.2, the arctangent. So you can see the sine t here. The sign we have here is tan, and the next one is arctangent. So we go arctangent of 3.2, we close bracket, equals this. So that gives us 72.646. So we come here, this gives us 72.646. Now this is your reference angle. Now the next step you take is, now this is the first step. The first step is you find the reference angle. The next step you do is, which quadrant do we have the tangent to be positive? Because what we are told here is the angle lies between 0 and 2 pi, and then it is positive. Now what you recall from the last videos we have done so far is, of all the quadrants, which of the quadrants can we have the tangent to be positive? So we said we have A, you have C, you have T, you have S. So if it lies here, this is all positive. It is going to be positive. So any angle that lies between 0 and we say this is 90, this is 180, this is 270, while this is 360 degrees. So if it lies here, it is going to be positive. And then also, if it lies in its quadrant, it is also going to be positive. But if it lies in the sine quadrant or the cosine, it cannot be positive. So that brings me to my next step. So since I've been told that tan theta is positive, so the only option is that either the angle lies in this quadrant, this is the first option, or the angle lies in its quadrant, in its tangent quadrant. Now if the angle lies in this quadrant, you've been told that the reference angle is 72.46. Sorry, 72.646. 72.646. So with respect to this diagram, the reference angle is the angle it makes with the horizontal axis, and that is 72.646. So this is for the first case. Now for the second case, which would make it to be positive, the reference angle with respect to this, we said is the one it makes with the horizontal axis, and that is 72.646 also. So having known this, the next thing is let me now find the angles. So the angle, the original angle now, that is the original angle is just, we start from here and then we go here. We always start from the positive x-axis up to where the line reaches. So for the first one is 72.646. What of the second one? That is for theta 2. Now for the second case, how do we get the original angle? Now for you to have obtained this line, it must have been that you have started from the positive axis, because we said the original angle starts from the positive x-axis and then you begin to go until you get to the original angle. So this is the original angle. What you have here is only the reference angle, but for the original angle you have to start from the positive x-axis like we have done before until you get here. Now if from here to here is 72.646, and we know that from here to here, that is this whole place here, is 180 degrees. So how do you find the whole of them? So the whole, which is what you have here, is going to be 180 plus 72.646, and that is actually going to be 252.646. So in other words, your theta 2 is 180 plus 72.646, which is 252.646. So what we have been told is, we said round your answers to 2 decimal places. So to round this to 2 decimal places, this is going to be 72.65, and then this is going to be approximately 252.65. So these are the two solutions we obtained. Now you might be a little puzzled that could this be true? Let's see, let's confirm. So you recall, our answer must be that the tangent of the angle must be 3.2. So the tangent of theta must be 3.2. So what we want to do is, we want to check. Now to check for theta 1 is 72.65. So I'm going to check if the tangent of 72.65, what is this going to give me? And then I'm going to check for the other one too, which is for theta 2, that's the tangent of 252.65. What will this give me? So let's use our calculator. So we go to on. So let's find the tangent. So second function t of 72.65. So that gives us what? You can see we obtained 3.222 something, and that's going to be 3.2. So this is correct. So the next one is 252.65. So we go again. So let's clean this. 252.65. We obtained the same thing, 3.222 something. So that is 3.2. So that's correct. So if the whole thing seems a little confusing to you, I'd advise you watch the video again. You would get the whole picture. I'm very sure you would get the whole picture, because I think it's very interesting.